So 3.1 states the fourth term of an arithmetic sequence is -3 and the 20th term is -35. Determine the common difference and the first term. So we need to find D and we need to find A. We are told that the fourth term is equal to -3 and the 20th term is equal to -35. So what we are now going to do is we are going to create two equations and then solve simultaneously, okay? So this is question 3.1. So I'm going to make a list of the given information. You'll see that in all the classes, whether it's math or it's physics, I like to make a list of what is given. It makes it easier to solve the question. So we are told that term 4 was equal to -3. In addition to that, we were told that term 20 is equal to, was it negative or positive? It was -35. So this is the information that we are given. We now need to find A and we need to find D. So we know that our general term is Tn equals A plus D into n minus 1. From here, I'm going to start with T4. So I'm going to substitute n equals 4, and I'm going to substitute T4 equals -3. You'll see from that, we will end up with two variables within our equation. So let's start. So term 4 is equal to A, which is unknown, plus D, which is unknown, into 4 minus 1. Take note that all I've done is substitute n equals 4. From here, I will substitute the value of term 4, which is -3. And we have A plus D into 3. Now, I'm going to solve for A because I'm going to connect my equations at the point A. So I will then have -3 minus 3D equals A. This is my first equation. Before I move on to the second equation, does anyone have a question or is anyone confused by what we just did? Okay, so let's move on. The next equation, I'm going to use term 20 or 20th term. That means my value of n is going to be 20. A is still unknown, D is still unknown, and n is 20. From here, I can substitute term 20, which is -35, is equal to A plus 19D. From here, all we now need to do is solve for A because I want to connect my equations at the point A. Take note that this is not the only way to solve simultaneous equations, okay? There's multiple methods that you can use. So before I continue to connect the equations, does anyone have a question? Is anyone confused by what we've just done? Okay, so let us continue. So from here, I'm going to connect equation 1 and equation 2. So we have -3 minus 3D equals -35 minus 19D. All we now need to do is solve for D. We need to find the constant difference. Once we find the constant difference, we will then be able to solve for A because we can substitute D back into either equation 1 or equation 2. So from here, we'll move everything that has D to the left, everything that is a constant to the right. So -3D plus 19D equals -35 plus 3. From here, that gives us 16D is equal to negative 32. Therefore, D is equal to negative 2. That means that the constant difference is negative 2. If we want to find the next term, you just keep on adding negative 2 to the previous term to get the next term. Now, if we want to find A, I'm going to use equation 1. Keep in mind, you can use equation 1 or equation 2. It doesn't matter. So we substitute D as negative 2. And we therefore have A as equal to, let's just see, negative 3 minus 3 into negative 2. That gives me positive 3. So our constant difference is negative 2. And our first term is positive 3. We've now answered the question, and that was 5 marks. Question 3.2. Are we doing that or skipping?
We're doing it.
How would we start? We went through this last month when we did sequences and series in both of the classes. So what's our first step to evaluate the sigma? Who can tell me?
We have to expand it, sir.
How would we expand?
We're going to say 3. Then by k we place 1 minus 2. And then we have to get our first term. Then we're gonna do that and keep on replacing the k with 2 and 3, so on.
That is correct. So all we're now going to do to expand the sigma is we're going to substitute k equals 1, k equals 2, k equals 3, and so on. However many terms you want to get, that's completely up to you. But we are going to continuously substitute from k equals 1 into this general term so that we can build a pattern. I'm only going to find the first 3 terms. So I will substitute k equals 1, k equals 2, and k equals 3 to find the first 3 terms. So it's 3 to the power k minus 2. So we have 3 to the power k minus 2. We are starting at k equals 1, so it's going to be 1 minus 2, plus 3 to the power 2 minus 2, plus 3 to the power 3 minus 2, and so on. I'm only finding the first 3, okay? Let me go back and double check the general term. Okay, yeah, it is fine. So from here, if we put this into our calculator, we have 3 to the power 1 minus 2. That gives us 1 over 3, right? Plus, put the next one into our calculator. That gives us 1. The next one into our calculator, that is going to give us 3. So that is the first 3 terms of our series, right? All we now need to do is find A and find R and find N. As you can see, this is a geometric sequence, right? So A, R, and N. I'm going to go back to the question and I want you guys to tell me what is our value of N. Who can tell me how we are going to find N, or if you already know what the value of N is? How many terms are there?
There are 20 terms, sir.
And how do we know that there are 20?
We'll say 20 minus 1, which is the bottom, then plus 1.
That is correct. That is correct. So if we want to find the number of terms, all we are going to do is top, which is 20, minus the bottom, which is 1, plus 1. So irrespective of what the numbers on top and the bottom are, you always just plus 1 at the end. So our value of N is 20. Our value of A is 1/3, and our value of R, our constant ratio. In order for us to find the constant ratio, we can take term 2 and divide it by term 1. Alternatively, we can take term 3 and divide it by term 2. If we do that, we end up with R as 3. Now, take note that we needed to find or to evaluate that sigma, meaning that we needed to find the sum of all 20 terms. If you want to do this without a formula, which is a long way to do it, you find all 20 terms and you add them up. If you want to use a formula, which is much faster, you expand the sigma, find the number of terms, find A, find R, and then you can use your formula. So the sum of n terms is equal to A into 1 minus R to the power n all over 1 minus R. From here, we can substitute n as 20, A as 1/3, and R as 3. So the sum of 20 terms is equal to 1/3 into 1 minus R, which is 3, to the power 20, all over 1 minus R, which is 3. You can put that into your calculator. So let's see, 1/3 into 1 minus 3 to the power 20, all over 1 minus 3. That gives me quite a large number. So it is going to be 581,130,733.3. So it is quite a big number. And that is question 3.2. So before we continue, does anyone have a question, something they do not understand, or something that we need to repeat regarding question 3.2?
So how do we know if it's geometric or arithmetic?
By the general term. So if we go to this question over here, 3.2, do you see that your variable, that k, is an exponent? That should remind you of the general term of an arithmetic sequence. Do you see that the variable is your exponent? If it was arithmetic, it would have looked like this. So, for example, you could have had like 3k plus 1. Do you see that your variable is not an exponent, it's a base, or it's on the ground?
Yes, sir.
Let me see if I can find another example of an arithmetic one. Okay, so do you see this one over here? Do you see you are substituting for t? So it's going to be geometric because the variable that you are substituting for is an exponent. Then I do not see here as well. Do you see the general term? Because that variable is an exponent, it's geometric. I do not see an arithmetic one. Okay, so both of these are also geometric. I don't really see an arithmetic one right now, but just always remember that an arithmetic one, your variable that you're going to substitute for will be a base, okay? Does anyone else have any questions before we move on to 3.3? Okay, so then let us move on. So question 3.3. Are we doing 3.3.1 or skipping?
Wait, to what, sir?
Okay. So question 3.3.1 states, the following sequence forms a convergent geometric sequence. Who can tell me what does convergent mean in this context?
So isn't that when the value is between -1 and +1?
That is correct. So when a sequence is convergent, your value of R, meaning your constant ratio, has to be bigger than -1 or smaller than +1. Meaning it can be -1/2, it can be +1/2, 1/3, whatever it is, as long as it is between -1 and +1. Okay, that is a convergent geometric sequence. Now, the question states, we've got determine the possible values of X. So take note of the way the question was asked. They said possible values, plural, meaning that we are going to basically have an inequality or a range of values. We won't only have one value, okay? So we need to determine the possible values of of X. So what we are now going to do is, because they stated that it is convergent, we will find the value of R, substitute R into this equation, and then solve for X. Those will be the possible values of X that will make this sequence convergent, okay? So let us start there. Our first step is going to be to find R. We won't get a numerical value, but we will have a value of R in terms of X. And we know that in order to find R, we are going to take term 3 divided by term 2, or term 2 divided by term 1. So what do you want us to do? Are we taking 4 divided by 3, 3 divided by 2, 2 divided by 1? Which do you want to do?
Two divided by 1.
2 divided by 1. Okay. If I was doing this, I would recommend you to use I would rather you use 1/3, since there's less variables in there. But it's completely up to you. You can choose what you do at the end of the day. So term 2 divided by term 1. So this is question 3.3.1. We know that R is going to be equal to term 2, which is 1/x minus 1. Divided by 3/x minus 1 squared. Now take note that I'm not using a division line at the bottom, because I know it can sometimes get confusing. So because I'm dividing a fraction by a fraction, I'm just going to proceed with a normal division symbol. So term 1 we said is 3/x minus 1 squared. So from here, all we are now going to do is turn that division sign into a multiplication sign. In order to do that, please take note that you flip the fraction after the sign. I've seen multiple people that flip the first fraction. You need to flip the fraction that comes after the sign, okay? So we're going to flip 3/x minus 1. So that is going to give us R equals 1/x minus 1 times x minus 1 squared over 3. From here, you can see that x minus 1 will go into x minus 1 twice. So our constant ratio is therefore going to be x minus 1 all over 3. That's our ratio. From here, because they stated that this is a convergent geometric sequence, we are going to take this value of R that we have calculated and substitute it into the formula that was mentioned at the beginning of this question. So we know that our convergent geometric formula is -1 to 1. From here, we substitute the value of r, and we end up with -1 to x minus 1 all over 3 to 1. Now, keep in mind we need to solve for x, right? So how do we solve for x from here? What do we do? Am I going to cross multiply the 3 to the right or to the left,
Yes,
or
yes.
both?
Yes, it's going to be -3 less than x minus 1 less than 3.
So is it only to, sorry, you said less than 3, so you're also putting it on the right, on both sides?
Yes, you multiply.
That is correct. So we're going to multiply that 3 to both sides. Because you have what is known as a three-prong equation or a three-prong inequality, you need to do it on both sides. You'll see later on, you might come across things that look like this, or an equation that could look like this. So there's two equal signs. That means that whatever you do to the left side, you'll also do to that right side. So if you are multiplying by 3 on the left, you'll multiply by 3 on the right. You need to do it to both. You move it to both sides. So from here, we have -3 to x minus 1 to 3. Now, this -1, we are going to move it to both the right and to the left side. And take note that it becomes positive. So on the left, we will have -3 plus 1. On the right, we will have +3 plus 1. So that is now going to give us, let's see, -3 plus 1 to x to +3 plus 1. We now know that x is between -2 and 4. So the possible values of x are between -2 and 4. Please take note that there's no equal to sign as well. That means that it's not at -2, nor is it at +4. It is between those values. So it could be at 3.99, it could be at 3.98, it could be at 3, at 2, at 0, at 1. At -1, but it is not at -2, nor is it at +4, nor is it any values outside of that area. It is only between -2 and +4. So please take note of that. So those are the values of x that will result in this being convergent. Before we continue, does anyone have any questions?
No, sir.
Okay, so take, yes.
If x was negative, we will have to divide by negative to all the left.
So if it was like this, if there was a negative in front,
Yes.
Yes.
yeah, then you change the sign. So when you divide by negative, it would have then become 2 greater than x greater than -4, like that. So anytime you divide by a negative, you change the sign of the inequality. Did I give you guys access to the grade 11's shared folder? You don't? Okay. I will give you access to the grade 11 shared folder. I think we went through inequalities a few weeks ago, but there are a lot of concepts from grade 11 that you still need to know in grade 12. So yeah, I will give you access to the grade 11 shared folder, and I will post the grade 11 meeting links in the grade 12 group as well. You can attend those for revision purposes, okay? When I say revision purposes, take note that even though it is revision, it's still examinable in grade 12. You need to know it in grade 12, okay? But yeah, before we move on, does anyone else have any questions?
So, when you
Yes.
are cross multiplying, What happened to the exponents on x minus 1?
When I cross multiplied, so this 3 went to the right and this 3 went to the left. So here it became -1 times 3 and +1 times 3 because I cross multiplied. Then the -1 stayed there. I didn't move it as yet. Was that your question?
No, sir. Here it x minus 1 to the power of 2.
Okay, just give me a second to find. Oh, okay, wait, never mind. I know what you're talking about. This one over here.
Oh.
So that one over there, remember I stated that x minus 1 goes into x minus 1 all squared twice. So if you were to divide them, just give me a second to move this. So if you were to divide them, right, let's just expand it. So here we have 1 times this thing on the right. So it'll become x minus 1 squared. And here in the denominator, we have x minus 1 times 3. So it'll become 3 into x minus 1. Do you see that x minus 1 can divide x minus 1? It's that rule from grade 10 that states that when you divide like bases, you subtract the exponents. Now take note that your base is x minus 1. So you write the base once, which is x minus 1, and you subtract 2 minus 1, because take note the exponent here is 2 minus 1. Sorry, the exponent here is 1. So from there, you end up with basically 1 on top. That's how we got that. Another way of doing that is to take note that because it's squared, it means you can repeat the bracket twice. And I think most people would prefer this method. You just cancel out 1. So that leaves you with x minus 1 over 3. You okay with that?
Yes, sir. Thanks.
Okay. Before we continue, does anyone else have any questions?
No, I am.
Okay. Then please take note that another way of asking this is they sometimes state show that this is a show that this is a convergent geometric sequence, or prove that it is a convergent geometric sequence. That's something that I've seen quite a few times. So what you do in such a case is you find R, and then you just substitute R into that convergent formula. So let's say you did all your working out and you found that R was a half. To finish up, all you say is therefore 1 to a half to 1, and you're done. That's it. In place of R, you substitute the value of R. That is you showing or proving that this is a convergent geometric sequence, okay? So yeah. Then question 3.3.2. We've got if x is equal to 2. So now they gave us a value of x. So we proceed with this value. So if x is equal to 2, calculate the sum to infinity. Please take note that the sum to infinity formula and the sum of n terms formulas are different. I saw that someone mixed them up in one of the questions that I saw quite recently, someone sent me. So sum to infinity is equal to a over 1 minus r. Sum of n terms is equal to a into 1 minus r to the power n all over 1 minus r. So take note that the two formulas are different. If you confuse them or if you use the wrong formula in the wrong situation, you will get it wrong. So please take note of the formulas. If you struggle to memorize or remember formulas, please make use of the formula sheet at the back of your question paper. So we need to find the sum to infinity when x is equal to 2. So we know that the sum to infinity formula is A over 1 minus R. That means that we need to find A and we need to find R. We will find A by taking the first term, substituting x equals 2, and that will be our value of A, whatever we get from there. If we want to find R, we can take the first term divided by the second term, whereby we have substituted x equals 2, and we'll have the value of R. Alternatively, I think we solved for R in terms of x. Yeah, we did in the previous question. X minus 1 over 3. So if you go and substitute x equals 2, you will then have your value of R. So that is all we are now going to do. We are going to substitute x equals 2 into the first term. We will substitute x equals 2 into our equation of R, substitute all of that into our sum to infinity formula, and that is it. So let's start. This is 3 over x minus 1 squared. So 3.3.2. A is equal to 3 over x minus 1 squared. And we know that x was given as 2, right? So in place of x, we substitute 2. We put this into our calculator. I think it should give us 3, but let's double check. 3. So we now know that A is equal to 3. We go and grab our equation of R. We substitute x is equal to 2. We can put this into our calculator, and we now have R as equal to 1 over 3. So that is our value of A, that is our value of R. Before I move on to calculate, is anyone confused by how we found A and R?
Yes, sir.
When you say yes, does that mean yes, you were confused?
Yes.
Okay, what part are you confused by? Then I can explain. You said you confused, like what part?
In A is equals to 3 all over 2 minus 1 close bracket squared is equals to 3.
Okay, let's start there then. So if we go back to the sequence that we were given, right? We know that A represents the first term. Are you okay with that?
Yes, sir.
And if you look at the sequence in terms of X, which is the first term? Is it this one, this one, this one, or this one?
3 all over x minus 1 to the power 2.
That is correct. And remember in the question, they stated that X is equal to 2, right? So all you are now going to do, because you need to find an actual value, you need a numerical value. So you take this 2, you substitute it in place of X, you put that into your calculator, and that gives you the value of A. Are you okay with that?
Okay, yes, sir.
Are you okay with how we found R, or should we go through it?
I am okay, sir.
Awesome. So just to repeat once more, take note that X was given as 2, right? And in order for us to find the sum to infinity, we need to find A and we need to find R in order to substitute those two values into our sum to infinity equation. Now, we were given a sequence in terms of X. So if we want to find A, which is the first term, we substitute the value of X. If you wanted to, which I didn't do for the sake of time, you can substitute X into this sequence and get every value in the sequence. Then you can find A and R. So there's a few ways that you can approach this question. At the end of the day, do what works for you, do what you understand, and you'll be fine. So now that we've found the value of A and we have found the value of R, we are going to substitute into our sum to infinity formula, which is the sum to infinity is equal to A over 1 minus R. From here, we know that A is 3 and R is 1 over 3. If we put this into our calculator, let's see.
It's 9 over 2, sir.
That is correct. It is 9 over 2. So all we'll do is state, therefore, the sum to infinity is equal to 9 over 2, and we are done. That is the Gauteng 2022 March exam paper. Are we doing question 2.1 or jumping?
Jumping.
Okay. Are we doing 2.2 or jumping?
We're doing 2.2.
Okay.
Okay, yeah.
So
Fine.
question 2.2, we need to calculate the value of this. Basically, they've added 2 sigmas, right? So what I would recommend is do them individually, separate them. So take the first sigma, just give me a second. So take the first sigma, calculate it individually, how you would normally do it. So expand, find the sum. Take note that because infinity is the top value, you're going to use the sum to infinity. Then separately, calculate the second sigma. Take note that because the second sigma has a terminating point, it ends, you can use your SN formula, the sum of n terms. So take the first sigma, evaluate it separately. Take the second sigma, evaluate it separately. Once you find those 2 answers, add them up and you are done. That's all you're doing. Then here, because they stated give your answer to 3 decimal places, you already know that you are going to have a decimal, right? They would not have stated that unless you would have a decimal. So here you would leave your answer in a decimal form. So yeah, let us start. I'm going to start with the red one, okay? I'm going to ignore the green one for now. So with the red one, we've got the sum to infinity. R is starting at 2, and we've got 3 times 2 to the power 1 minus R. So all I'm going to do is substitute R equals 2, R equals 3, and R equals 4. I'm going to find the first 3 terms. Once I find the first 3 terms, I'm going to identify my value of A, I'm going to identify my value of R, and then I'm going to substitute that into my sum to infinity formula. So let us start there. This is 3 times 2 to the power 1 minus R. So question 2.2. So we had 3 times 2 to the power 1 minus R. Let me confirm. Yeah. So from here, R started at 2. So I'll substitute 2 plus, wait, R is at the back, sorry. Substitute 2 plus 3 times 2 to the power 1 minus 3 plus 3 times 2 to the power 1 minus 4, and so on. Take note that here it was R equals 2, R equals 3, and R equals 4. So all I did, I substituted R equals 2, R equals 3, R equals 4. If we put this into our calculator, that is going to give me 3 over 2
Plus 3 over 4.
You said 3 over?
3 over 4
The next one?
plus 3 over 8.
Okay, thank you. So those are our first 3 terms. We can see that A, which is the first term, is equal to 3 over 2.
Yes.
we can see that R, which is our constant ratio, is going to be 3/4 divided by 3/2. Alternatively, you can use 3/8 divided by 3/4. The choice is yours to make. So that'll give me, just give me a second. I get
It's
1/2. Okay, thank you. So R is 1/2. Now that we have the value of A and we have the value of R, we can put this into our formula. And A was 3/2. R was 1/2. If we put this into our calculator, let's see.
It's 0.75.
You said 0 point?
75.
Just give me a second to double check.
Yes.
1 minus 1/2. You said you got 0.75.
Yes, sir.
I'm getting 3. Can someone else also just double check on your side? It could be I've made a mistake, but just check if you get 3.
I'm getting
I also
I
got
also got
They also got
Okay.
3. Okay. So
Yeah.
remember, because it's a fraction over a fraction, please be careful with how you put it on your calculator. What I would recommend is press the fraction button, and this should
Okay.
pop up, right? Then press 3, then press the fraction button again. So if you've pressed the fraction button, put 3, then put 2, then press it again, your fraction is going to open up at the bottom. So be careful with how you use your fractions on your calculator. Alternatively, what you can do is on your calculator, put it as 3/2 divided by, then open a bracket, 1 minus a half. Okay, so that's an alternative way. I feel like this way, there's less chance of messing up, but fraction over fraction is a confusing concept on a calculator, so please be careful, okay? So from here, we've
Okay.
concluded that everyone got 3, right?
Okay, sir. Yes.
Okay, awesome. So from here, we have the sum to infinity as equal to 3. So we've not got a decimal yet, which means that most likely we will get a decimal for the next value, that green sigma that I highlighted. So this is the first sigma. This is the sum to infinity, the first part. Does anyone have any questions before we move on from here? Okay.
No.
Then let us proceed. So we have question 2.2, right? The green part. So if we focus on that green sigma, we've got 12 on top, means that 12 is the last value of R that we substitute. We've got 2 at the bottom, which means that 2 is the first value of R that we substitute. On a side note, what is my value of N for this?
11.
11.
Sir.
That is correct. Top, which is 12, minus bottom, which is 2, plus 1, and you get 11. So we now know that in the green sigma, there are 11 terms. So we are calculating the sum of 11 terms. From here, let's see. We need to find our value of A and we need to find our value of R, right? On a side note, you can even find your value of R straight from here. Please take note that R is not 2, but if you know how to use algebra, you'll be able to find R. If you want to use what is given in the sigma, just try and get it in the form that it's supposed to be in, n minus 1. Your variable must come first, okay? If your variable comes first, then you can use that value of R. And if it's only -1, if you have -2, -3, you can't use that. But if it is -1, you can. All you need to do from here is make that positive. So if you look here, right, if you take out the negative from that, it's going to be negative into -1 plus R. you can rewrite that as negative into r minus 1, okay? That is now the proper form. If you look here, the variable minus 1. Now, look at that negative in front. In grade 10, you learned that when you raise an exponent to another exponent, you can multiply them, right? For example, if you have 2 to the power 2 raised to the power of 3, you multiply them, which is 2 to the power 6. But you also learned another technique whereby you can swap them. So you can have 2 to the power 3 raised to the power of 2. It all means the same thing. You can even break it up into something different and have 2 to the power 1 raised to the power 6. These are just you making use of what you already know regarding factors. Because 1 times 6 is still 6, 2 times 3 is still 6, 3 times 2 is still 6. So that's just you manipulating what you already know regarding factors. Now, if we come back down here, if we add this to here, so we have 3 times 2 to the power negative into r minus 1. From here, who can tell me what are we going to do with this 2 to the power negative? What does that become?
You're going to
1 over
multiply
2.
That is correct. Whoever said 1 over 2, awesome. So that is a half to the power. Give me a second. That is a half to the power r minus 1, okay? So we've taken that 2 to a half, and it's in the proper form, the variable minus 1. So we now know that r is a half. So if you don't want to expand, you can just extract. Alternatively, you actually don't have to expand. If you look here, right, do you see that the general term is exactly the same? Do you see that the starting point is exactly the same? So if we're expanding, technically we're doing double. We're basically repeating the same thing. So if you want to, you can just go back down to where you expanded the first time and copy these values. So we know that n was equal to, I think we said 11, right? Yeah, no, where's that written? Okay, let's just calculate it again. 12 minus 2 plus 1, yeah, that is 11. I think I erased it maybe. So we know that n is 11, a is 3 over 2, and r is a half. From here, we're going to calculate the sum of n terms, which is a into 1 minus r to the power n all over 1 minus r. I know some people like to use this formula. Whichever one you use, that's completely up to you. I prefer to use the one I've written down. But yeah, if you want to use it, that's completely fine. We'll end up with the same thing in the end. So here, it's going to be the sum of 11 terms is equal to 3 over 2 into 1 minus, this is going to be a half. Please be careful with all the fractions that are in this formula. And 1 minus a half. So if you struggle with putting fractions on your calculator, what I would recommend is put this top part only and then write down the answer. Maybe it's like 5 or 4 or something, whatever it is, write it down. Then put the denominator into your calculator and that'll be a half, right? Then when you write it on your calculator, you'll say 4 divided by 1 over 2. That way you don't make a mistake with the fractions on your calculator. So please be careful with that, okay? Let's see. So this is going to give me 3 over 2 into 1 minus a half. Another thing, if you don't want to use 1 over 2, you can use 0.5. I feel like that's less fractions as well. So if it is possible to write it in a decimal form, do that as well, okay? So yeah. That is to the power 11 all over 1 minus a half. Did you guys get 2.9985 and so on?
Yes.
Okay, awesome. So they said round off to 3 decimal places, right? So sum of 11 terms is equal to 2,99. That'll also become a 9. So we've now found the green sigma and we found the red sigma, right? We have both of them. Now, if you look at the original question stated that we need to add them, and that is going to be our solution. So we take, I think it was 3, right? Yeah.
Yes.
So we take 3, we add that to 2.99, and that gives us 5.999, and that's the end. That is our solution. So if you feel comfortable and you feel confident enough to do all of this within the same line, you can do that. The reason you can do that is because the general terms are the same and the starting points are the same. That means they'll have the same value of A, they will have the same value of R. So if you wanted to, you could have just created one sequence. After you create that one sequence, you can then find the value of A, find the value of R, and then here you'll break it up like this. You'll say equals to A over 1 minus R plus A into 1 minus R to the power N all over 1 minus R. Then you can substitute and put the entire thing into your calculator. So if you felt like you were okay with doing that, you can also take that option. If you feel like you're not confident enough to do that, I would recommend breaking it up and then doing it separately and adding at the end. So if we conclude, we'll state 3 plus 2,999, and we end up with 5,999. That's our solution, okay? If we add up both sigmas, that is all we are going to end up with, 5.999. Take note, they said 3 decimal places, right? So, yeah. Does anyone have any questions before we end for today? Okay.
Sir,
Then, yes.
I have a question.